I'm going to take just 5 minutes of your time to introduce why the cluster adjustment is necessary. This is, as we said, this is the early phase of 2000. There are a lot of materials on cluster adjustment, why it is necessary. Tomorrow morning, I have an extensive lecture on cluster levels and adjustments and so on. As I said earlier, that cluster occurs in various levels. Therefore, it is up to you to find out whether am I dealing with that kind of clusters. As I told you, the doctor is a cluster, individual is a cluster, and so on. Doctors coming under a medical college is a cluster. And say, for example, the antenatal care data during the HIV/AIDS era. So we were able to use this model very effectively. And for Tamil Nadu, I will give you as an exercise. Each district is a cluster with periodically collected data. So therefore, you can analyze it and see. Similarly, you can use this concept at various levels. This is a trial community randomized control trial where 2 interventions were used. This is from Donor and Clark. They have written a book on cluster. So there are 2 books in the world for cluster analysis. One is by Alan Donor, another one is Richard Hayes from London School. And those days they were like Bibles. Now there are many books using GE and MLM. There are many books with a lot of data and so on and so forth. There are 12 schools were selected and randomized. It's a school-based randomized control trial. There are 2 interventions. One is that curriculum-based intervention to stop smoking, and the usual, another one is the existing curriculum, you put that part and train the students. So finally, you need to evaluate whether the smoke-free generation new curriculum is effective as compared to this existing curriculum method. So there were 12 schools here, and this is how many people are still smoking, the numerator. Therefore, you can calculate the proportion. So therefore, if I have to analyze this data, what I will do is I'll take the proportion as the outcome variable, which is a continuous, because you have 12 hospitals, assuming that this follows normal distribution and so on. Finally, you do a t-test or whatever to see whether there is any difference between the curriculum and all that. But as you see here, the children coming from the same school share the same environment. Therefore, quitting or not quitting smoking depends on the whole environment as well. Therefore, the school has to be considered as a cluster. So if I do the analysis in both ways, adjusting for cluster, what happens? What is the message that we get from the analysis? This is the data. The smoke-free curriculum generation new method deals with 58 out of this total. And this is still the 91 students are still smoking in this curriculum out of this total. This is, you need to find out the total. So therefore you have a total proportion. If you do a chi-square test, it says, yes, there is a significant difference between the 2 methods. But it is a simple method, okay? It doesn't take care of the clustering or whatever. The question is whether it is correct or not. This is unadjusted analysis using, this is a state output, this thing. You don't worry about what the software is used. This is when you use this as as you see here, this is a regression concept. Cluster survey, people who have used this data, use this method, survey analysis method. Linear regression. Linear regression, no adjustment at all here. So therefore, if you see here, the group is 2 groups, you have 1 and 2. So move from 1 to 2, new curriculum to existing curriculum. What happens? Let us not worry about that, because if we do this one, the p-value is 0.029 or 0.03. So unadjusted analysis suggests that there is a significant difference between the 2 methods of teaching. Is that right? Unadjusted analysis. That is what we were doing in 2000 and even 2010 and so on. So forth. This is adjusted analysis where you capture the clustering effect, design effect. We call it as a design effect those days. When you adjust for a clustering effect, it becomes 0.189. Okay. 0.189, it says that there is no difference between the two methods of teaching. So why it is not different? When you do a t-test, we take the difference and divide it by standard error. If the standard error is smaller, you obviously get higher t values. It will be greater than 1.96. Therefore, you will end up with saying it is significant. T square is chi-square, for example, in a 2 by table situation. So here, when you adjust for it, what happens is, if you see here, this is how much is a standard error, 0.0084. Here, 0.01. Do you understand this one? The unadjusted analysis, the usual simple analysis, gives you a smaller standard error. So therefore, the standard error in the denominator is smaller, therefore the t becomes larger. Therefore, you get significant result. So we call it as a false positive findings. Okay. So when you adjust for cluster, what happens is invariably the standard error becomes larger, and therefore you are less likely to get statistically significant results. Therefore, the journals insist on clustered analysis. Okay, so this is very important, and I must share with you this. I was helping Tambram Hospital. You know, near the airport, there is a TB hospital, the largest TB hospital in India, the first established TB hospital. That hospital was treating HIV patients for quite some time. In the year 2000, 2004, I was helping them with the analysis. But then each patient will visit the hospital nearly 1 day. Every month they will come, and it's the only hospital in India allowed to give 1 month medication for the patient. Otherwise, in the government setting, it is only 3 days or 1 week maximum. Here, the patients coming from Andhra, Karnataka and Tamil Nadu collect medicines for 1 month and come back. So invariably, they were visiting the hospital every month. Okay. So that is the first time we analyzed data to give what is the scenario happening in HIV patients in India. We analyzed the data. Then he said, when we sent the paper to AIDS, this is a very prestigious journal those days, outright they rejected it because they said, 1.5 million visits, 1.5 million visits of 45,000 patients, which we analyzed. So I did not have the software to analyze it. SPSS did not have that kind of thing. Data cannot handle it because 1.5 million visits and so on. It is impossible to do for me because invariably you can do it with the SAS and so on. So CD was helping me, but they said we'll give up, and so they rejected it because he did not analyze the data using the GE model because same patients are coming and again and again and so on. We were looking at the weight gain and hemoglobin values changes and so on. So therefore, what I wanted to tell you is it has become imperative that you need to adjust for clustering. If the editor or somebody else finds it out, this is a clustering concept. So you need to realize that. So the challenge is how do you find out the clustering? We'll do a couple of exercises and so on.